In section 10.2, we're going to be talking about ellipses. So what we talked about yesterday was a circle. So perfect circle is when you draw any point and then you draw the same distance out on either side, which would be your radius. That makes a perfect circle. An ellipse is like a perfect oval, so like a circle, but it's kind of smushed. So there's some different properties that we're going to talk about here and learn how to make an equation for them. An ellipse is a set of all points P in a plane such that the sum of distances from P to two fixed points, F1 and F2, is a constant K. So what I'm talking about here, if I had my two focus points and then a point P on that ellipse, those blue lines that I drew, the sum of distances of those would be the same as if I drew my point P here. It would be the same if I drew it here or drew it here. So that idea is how we make that perfect oval or perfect ellipse. The focus of an ellipse, plural here would be foci, is one of the two fixed points. So these guys here that I'm talking about. Let's talk about some major features of an ellipse. The major axis contains the foci and has its endpoints on the ellipse. So here in this example would be our major axis. I call my endpoints negative a0 to a0. My focus points are on that line. The midpoint of the major axis would be the center of the ellipse. The minor axis is perpendicular to the major axis at the center. And its co-vertices are the endpoints of the minor axis. And I would call that 0b and then 0 to negative b. Now, keep in mind, this is a horizontal ellipse. I could kind of rotate this a little bit and have a vertical ellipse, and my properties would change a little bit here. So vertical ellipse would look something like this. Now our major axis is on the y-axis, so going up and down. Those are where my focus points would be here. My minor axis would look like this. So notice how like the A coordinates and the B coordinates kind of changed a little bit here. Something to remember or help you remember this is I would say the major axis is always going to be your longer axis. So that's going to tell you whether it's horizontal or vertical. Finally, let's look at properties of an ellipse. These change a little bit depending on if it's horizontal or vertical. Definitely make sure you have these written down and highlighted, starred, something that you could easily refer back to in your notes. The standard equation for a horizontal ellipse would be x squared over a squared plus y squared over b squared equals 1, given that a and b are greater than 0. For a vertical ellipse, very similar, but one small thing changes here. My equation here would be x squared over b squared plus y squared over a squared equals 1. The major axis for a horizontal ellipse would be a horizontal line. For vertical would be a vertical line. My vertices for a horizontal ellipse would be plus or minus a, comma 0. For a vertical ellipse, 0 plus or minus a. My co-vertices would then kind of reverse. For a horizontal ellipse would be 0 plus or minus b. For a vertical ellipse, plus or minus b, comma 0. And finally, the focus points here, again, remember, are going to be on your major axis. My focus points for a horizontal ellipse would be plus or minus c, comma 0, and those are going to be on the x-axis. And then for a vertical ellipse, it would be 0, comma plus or minus c, as these focus points would now be on the y-axis. So let's look at our first example problem here. We'll just look at a couple today. What is an equation in standard form of an ellipse centered at the origin with a vertex at negative 6, 0 and a co-vertex at 0, comma 3? Now, the key feature here, what I'm going to want to figure out, is this vertical or horizontal? Because that's going to depend on that's going to change what equation I'm going to use. If I just made like a rough sketch right now, I have a vertex at negative 6, 0, so it means I have another vertex at 6, 0. And then I have a vertex at 0, 3. Just kind of sketching that out, I would realize, okay, this has to be horizontal. So my A value here is going to be 6. My B value here is going to be 3. So plugging that in, 6 squared, 3 squared. My equation here would be x squared over 36 plus y squared over 9 equals 1. And I'd be done. This will be important for doing the next problem. If plus or minus a, comma 0, and 0 plus or minus b, and plus or minus c, 0 are the vertices, the co-vertices, and foci of an ellipse, respectively, then c squared equals a squared minus b squared. This kind of is leading into the Pythagorean theorem, which we could talk about a little bit more tomorrow in class. But know this formula. Knowing this formula is going to help us find either a missing focus point, vertex, or co-vertex. So again, I would make sure this formula is written down too. Example number 2, what are the foci of the ellipse with an equation 25x squared plus 9y squared equals 225? Graph the focus points and the ellipse. So first, let's kind of get this equation into standard form. To know that I'm in standard form, I want my equation to equal 1. So an easy way to do that is to divide everything by 225 here. When I do that, everything's going to kind of cancel and look kind of nice. So when I simplify, I get x squared over 9 plus y squared over 25 equals 1. 25 is greater than 9, and the 25 are that bigger number is with the y squared. So that's indicating to me that this has got to be a vertical ellipse. So my a squared value would be 25 in this case. My b squared value would be 9 if I look back on my standard form equation for a vertical ellipse. And then to find my focus point, this is where this equation is going to come in. My c value, or c squared, is a squared minus b squared. So 25 minus 9, I get 16. Square root both sides. I get that my focus point is plus or minus 4. Moving along here, my b value is plus or minus 3. My a value plus or minus 5. When I want to graph this, since I know this is vertical, this is how I'm going to graph these points out. And again, another way to remember, I know this is vertical, so the plus or minus 5, like that's going to go further. So I'm going to plot 0, 5 to 0, negative 5. My focus points are on that major axis line, so it's 0, 4 and 0, negative 4. And then I graph and I plot all my points, and I'd be done. Last example, what is the standard form equation of the ellipse shown? So here I'm given a picture, I want to make an equation. Just looking at that, you could probably tell this is horizontal. So I want to use this form of my equation. I can see that my c value is plus or minus 5. My a value is 8. I just don't really know what my b value is, and it looks like it might be a little bit off. It's not exactly on a coordinate there at like 4 or 5 or negative 5. 6 or negative 6. So to find my b value, again, I'm going to use this equation. So 25 equals 64 minus b squared. Now I solve for b. I get negative 39 equals negative b squared. Cancel out those negatives. Now, the square root of 39 isn't going to be a perfect number, but looking at that equation, I just need to figure out what b squared is. So I could pretty much stop there and plug into my equation. The standard form of this equation is going to be x squared over a squared, which is 8, plus y squared over 39, which is b squared, equals 1. And I'm done.